Hello viewers, in today's class we are going to discuss another problem from integration involving greatest integer function. So here we have to evaluate this important integral from 1 to 2, and here we have log of the greatest integer of x square minus 4x plus 9. Right now see, here we have the natural log, and here we have a quadratic polynomial inside the greatest integer function symbol. So let us call this integral I, and we'll solve this integral using the concept of substitution method, and then we'll apply the definition of greatest integer function. So here what we will do, we have x square minus 4x plus 9. So let us express this quadratic polynomial in terms of perfect square, right? So we can write this polynomial as x square minus 4x plus 4 plus 5, and now we have x square minus 2 times x plus 2 square plus 5. So this is x minus 2 whole square plus 5, right? So now we can write this integral as 1 to 2, and we have log of greatest integer of x minus 2 square plus 5, and here we have dx, right? So now from here what we will do, we'll take help of the method of substitution. So let us take or introduce a new variable, say t, and t is equal to x minus 2 square plus 5, right? Now let us express x in terms of t. So we can now write t minus 5 is equal to x minus 2 square, and x minus 2 can be written as square root of t minus 5, right? So x is now 2 plus square root of t minus 5. So now we have expressed x in terms of t. So let us differentiate x with respect to t. So the derivative of 2 is 0, and the derivative of square root of t minus 5 is 1 over 2 times square root of t minus 5, and by chain rule the derivative of t minus 5 is 1 minus 0, right? So now we can write dx over dt is equal to 1 over 2 times square root of t minus 5. So now dx can be written as dt over 2 times square root of t minus 5. So now let us change the limits accordingly. So here the lower limit is 1. So when x is equal to 1, we can calculate the value of t from this expression, right? So the value of t is 1 minus 2 whole square, and here we have 5. So taking x is equal to 1. So we have minus 1 square plus 5. So this is 1 plus 5, that is 6. And when x is equal to 2, that is the upper limit, so we have t is equal to 2 minus 2 square plus 5, and 2 minus 2 is 0, so 0 square plus 5, that is simply 5, right? So now let us rewrite this integral I in terms of t. So we have now 6 to 5, because when x is 1, t is 6, when x is 2, t is 5, and here we have log of greatest integer of t, because x minus 2 whole square plus 5 is equal to t. So here we have greatest integer of t, and for dx we can write dt over 2 times the square root of t minus 5. So now we can also write this integral I as a negative of integral from 5 to 6, and we can take this half outside the integral, and we have log of greatest integer of t, and here we have square root of t minus 5 and dt, right? So we have interchanged the limits because we have used this property a to b f of x dx is equal to negative of b to a f of x dx, right? Now see, the limits of integration now varies from 5 to 6. So when t lies between 5 and 6, then the greatest integer of t, by the definition of greatest integer function, the greatest integer of t should be equal to 5, right? Because here t varies from 5 to 6 and there is no integer lying between 5 and 6, right? So t lies between 5 and 6. So the greatest integer of t should be equal to 5. So here we can write now I is equal to minus half, and here we have 5 to 6, and we have log of 5 divided by square root of t minus 5 dt, right? And now a log of 5 is a constant, so we can take log of 5 outside the integral, and we have 5 to 6 and t minus 5 raised to minus half dt. So now we have a very simple integral. So now the integral of t minus 5 raised to minus half is equal to, we have t minus 5 raised to minus half plus 1 divided by minus half plus 1, right? And limits are from 5 to 6. So here we have used the result that is the integral of u raised to half du is u raised to half, here we have negative half, so we have negative half plus 1 over minus half plus 1, right? So this is now minus half log of 5, and here we have t minus 5 raised to half, and here we have half, and limits are from 5 to 6. So now this 2 and this 2 get cancelled, and we have minus log of 5. And now we can substitute the limits here. So when we take 6, t is equal to 6, we have 6 minus 5 raised to half, minus when we have t is equal to 5, we have 5 minus 5 raised to half, right? So this is minus log of 5, and here we have 1 raised to half, that is simply 1, and this is 5 minus 5 0, so this is 0, right? So we have here 1 minus 0 is 1, so we have minus log of 5, or this can be written as log of 1 over 5, right? So the value of this integral is equal to the natural log of 1 over 5.